Okay, welcome to part 2 of day 2 of conics. This section is going to be over hyperbolas. And a hyperbola is going to look a lot like a parabola, but there's going to be 2 of them. So with the vertices facing each other, we also still have foci, or focus, inside them. The difference with these, aside from having 2 of these compared to a parabola, is that we will have asymptotes. And the asymptotes will go diagonally between these. Where our asymptotes cross is right in the center. So we have a center, a vertex, and then a focus. And just like we had in the other section, the distance from the center to the focus will be c. The distance from the center to a vertex is a. So those are a's. To the focus is c. So that's the same as what we had with an ellipse. Okay, the other thing is, though, where does b come into play? And b is going to help go up or down, so the opposite direction as the vertex. And we are going to be building a rectangle in the center of our hyperbola. Our asymptotes will go through the corners and the center of this rectangle that we build. So that's what's going to help us build this and graph it. Okay, a couple of things to note as we look at our hyperbolas. The equations for our asymptotes are given right here. So y minus k equals plus or minus, if it's horizontal, b divided by a times x minus h. If we have a vertical one, notice the a is on the top. If we have horizontal, b is on the top. And this is going to just give you the slope of your asymptote. Okay, so let's take a look at our equations here. Hyperbolas, by definition, are the set of all points where the distance to each focal point have a difference of 2a. So we'll be taking a look at these and seeing how everything plays in here. And our first one we're going to look at is, we got our equation right here. Notice that one term has to always be subtracted from the other. In this case, it's going to be the y variable is getting subtracted. And if I'm looking at my equations, horizontal hyperbolas are going to open right and left, so just like parabolas, and they will have the minus sign before the y term. So if our y term is getting subtracted, we will have a horizontal equation. We will have a vertical hyperbola, which looks like this, opening up and down. And it's going to be, oh, let's fix this. There's a typo right here. There should be a minus sign between these two terms. So if it's vertical, the x term is going to get subtracted, not the y. The other things to notice in the equation is under the positive variable, so in this case the x, in the vertical one it's going to be the y, we have the a squared. So a is going to be under the positive variable. This variable getting subtracted will have the b squared under it. So let's take a look at this one. We've got x squared over 9 minus y squared over 4. So this is really x minus 0 squared and y minus 0 squared. So my center is at 0, 0. So let's go ahead and plot that. And the fact that the y is getting subtracted tells me that this is going to be a horizontal equation, right? Because the x is squared and it's positive. The a value is always under the positive variable, so the 9 represents a squared. So the square root of 9 is 3. That gives me my a value. B comes from what's under the subtracted variable. So the square root of 4 gives me my b value. And finally, c, we're going to have to calculate. Now notice down here, we are using our Pythagorean theorem. A squared plus b squared equals c squared. So I've got a and b, so I can calculate c. So I've got a squared is 9 plus b squared is 4 equals c squared. So 9 plus 4 is 13. So 13, square root of 13 equals c. And we'll go ahead and put that. Okay. Okay, so An approximate value will be good as we go to graph. So that's approximately 3.6. And I got that just from plugging it in the calculator. So now let's see how we actually use these points and this data. To find where my vertex is, I always will be using the A value. So the vertex is what's going to be found using A. Now since this was a horizontal, we probably should write that, this is horizontal. So that means it opens to the right and left. So I need to go right and left by 3 units to get the vertex. 1, 2, 3. There is a vertex. 1, 2, 3. There is a vertex. So at -3, 0, and at +3, 0, I have my 2 vertices. The foci, which again, we use foci because it's plural, I find these by using the C value. So C will get you to the foci. And you might want to remember that C, and there's a C in foci. So I'm going to go approximately 3.6 units to the right and left. It's on the same axis as the vertex and the center. So 1, 2, 3.6, not very exact, but 1, 2, 3.6. So that's a focus, and that's a focus. Okay. Now if you remember, we said we would have to, let's write in our values here. So the focus is going to be found by adding and subtracting the square root of 13 to 0. So I am quite okay if we put plus or minus the square root of 13, comma 0. If you would rather put in the decimal value, that's okay, but this is how we find it. Okay, and for the sake of doing this, I'm going to show you how we find the asymptotes equations. We will be using the equation up here, but I'm going to show you an easier way in just a second when we go to graph it. So horizontal y minus k, well k was 0, so we just have y equals plus or minus the b value divided by a, so 2 divided by 3 times x minus h. Well, h was just a 0, so this will be my equation of my asymptotes. Plus or minus 2/3 x plus 0. So my y-intercept will be 0. The slopes are going to be 2/3 and -2/3. So we could certainly go in and graph that. And let's go ahead for the sake of this. I'm going to graph my asymptotes. We'll do the positive one first. So I go up 2/3 for my y-intercept. And let's do then down 2/3, down 2/3. And we would draw that in with a dashed line because we tend to show asymptotes with dashed lines. I have to show the -2/3 x equation also. So 1, 2, 1, 2, 3, 2. And we will go in both directions. And notice that these are crossing at our center of our hyperbola. This will always happen, that our asymptotes cross at the center. Now the other thing we're going to do to help draw our hyperbola in is I'm going to actually use the b value, because you notice we haven't used that anywhere. This distance right here was c, and the distance to the focus was a. So b actually does exist, and b we're going to go the opposite direction, or 90 degrees from where we would go for the vertex. So I'm going to go up 2 and down 2 from the center. And now what I'm going to do is create a rectangle right in the middle of this. I know there's a lot of stuff going on, but just bear with me for a moment. We're going to create our box, our rectangle, that goes through the vertex and goes through those dots we put that were b distance away from the center. So this distance right here is b, this distance is b. This distance right here is a, this one is a. So the length across, or the distance between our 2 vertices, is 2a. And now the thing I'd like you to notice is that your asymptotes go through these equations, or these corners and the center. So these are diagonal lines going through the opposite corners of your rectangle and the center. So this is what's going to help us draw our parabola in. The parabola now is going to use those asymptotes and touch the vertex. So there's one side of my parabola, and here is the other side.